Hi, I'm Hiro. I'm an application controls engineer and cybersecurity professional, and I've been in automation for over 14 years. Funny thing is, I actually started out as a mechanical engineer and made a switch to controls. Back then, when I started in controls, I struggled to find solid resources that explain how to write structured, sustainable control code. So now I am sharing what I have learned, and I hope that this will help folks who are new to industrial automation or programming in general. In this video, I'll show you 3 practical ways to control a pump in structured text specifically: a simple on-off latch, a timer-based method to prevent short cycling, and a lead backup failover setup. I'm going to walk you through the code, demo each one of them, and share a template you can reuse at the end. But before we go there, I have an important notice that I have to read. These templates are provided as is without any warranty. Hedgetech System LLC and its author assume no liability for any direct or indirect damages, injuries, or death resulting from the use of this code in any system. It is your responsibility to integrate and test the code fully in your own environment, ensure compliance with safety codes, regulations, and engineering standards, verify that all logic is safe, functional, and sustainable for your application. Use these templates at your own risk. They are intended for educational, personal, or internal organizational use only. So, with that scary warning out of the out of the way that I had to give because of the region that I am in, let's jump in to the fun part and let's look at the code. So, the simple on-off latch. Here you see it written out in ladder logic because most folks are really familiar with ladder logic. I also started out writing code in ladder logic myself. So you have a start command here that's going to turn on this pump run, and that's going to hold that signal here because of this branch here on the run. And if a stop command is issued or given, then that's going to interrupt this here and stop, basically turn off that pump run command. So the way that's written in structured text is actually very simple too, and you can achieve it also with one line of code. You have the start command here that's going to turn on the pump, and that's going to hold that command until a stop command is issued. So let's run that code and see what happens. Okay, so here I am online with the controller. I'm going to send or issue the start command to this small logic that I wrote. And as you can see, I get the pump run command or output here. And it really doesn't matter if I lose that start command, it will continue to be on until I hit that stop button, which is the expected behavior here. So that was really simple, really easy. Let's move on to method 2. So method 2 is, I actually have prepared a ladder logic here that just kind of describes the principle behind it. It's actually a little bit, the structured text code that I'm going to show is not going to fully reflect the ladder logic code. I'm going to give that um, as a footnote there, but the principles behind it is going to be the same. So we have the start button here that's going to issue a start command. That start command is going to be fed here into the TON. That's going to start this timer that is set to 10 seconds for now. And again, this will vary depending on the system. Will vary depending on the system that you are controlling, right? So just keep that in mind. And this last rung here, what I'm doing is I'm actually manufacturing the timer bit, because in CODESYS you actually don't get the timer bit, or like you are actually timing, or a bit that comes on whenever the timer is actually timing. Like other system, like if you're working with Allen Bradley, I think you have a timing bit. So I'm actually manufacturing that here, and I'm going to catch that here into this run, so that this start command will continue to keep on or be true even if we lose the start button, as long as the timer is on, right? Or this could be the start command or the start signal, actually, not a button, because a button you will press and you will let go. It will be more like the start signal. But let's look at that on the minimum runtime structured text example. So here I have this a similar code in structured text. I'm gonna go ahead and zoom in for you guys so you can see it. I have the start button. that is going to turn on the pump, and I'm going to latch that with the timing bit right here. I'm manufacturing the timing bit right here, and here's the timer. And the timer comes on whenever it receives that pump run command or sees that pump run command. And it's going to time for the time that I have specified here, which is also 10 seconds, right? And the reason why this looks a little bit different than the on-off latch, is because the stop command here for the on-off latch had ultimate authority to stop the pump, so to speak, right? Whenever that stop command is issued, it will always stop it. In here, it's a little bit different. We want the timing bit or the timer to have authority over the stop command. And again, I do have to share this, that in other systems, you might actually use what is known as the anti-cycle or anti-cycle timer or the interval timer instead, where once the pump stops, it can't start again until the delay expires, right? And the reason why you create code like this, it, the goal, I guess, the goal that you create code like this is always the same, and it's to extend the equipment life, because you want to prevent short cycling of an equipment or a pump in this scenario, right? But just know that for different applications, different industries, um, it may look different, and you always have to follow the specifications that is given to you of the code that they want you to create for them to control that specific piece of equipment. So with that out of the way, I'm going to continue here, and let's just jump on in and run this simulation really quickly. So I'm going to issue the start button. It's going to turn on the pump, and you can immediately see that this starts timing. If I remove that start button and let's say I issue the stop command, even though I'm issuing the stop command, you saw it right there, it will not stop. And that was kind of really real quick. So let's do that again real fast. So I hit the start button, and I'm gonna try to stop it, but you will see that it will hold that run output. Oh, and that's not what I intend to do, until that timer expires, and that's when the run output goes off. So that's method number 2. And now let's move on to method number 3. And this is when we're gonna actually do a little bit of something that is more interesting, and that might actually reflect something closer to what you may see on a real system. And that's when you have a lead and lag pump setup, or some people might call it pump staging or lead and backup, right? I'm going to zoom in here a little bit for you guys so you guys can see better. Okay, so let's go over the code really quickly here. Whenever you issue the lead run command, as long as that lead pump is healthy, so you have a fault, you're monitoring the fault on that pump, and you're also monitoring the overload. And I just added this level OK here just to add some extra interlocks or permissive signals that you may be monitoring on a real system. As long as that's healthy, we're gonna issue this lead desire command, which is gonna be cut here. That's gonna send this output. These are the outputs right here, right? And we have the timer, the minimum run timer, and we're manufacturing that timing bit here, which we use it to hold that output. However, if that something happens to the lead pump, there's a fault or there's an overload, it will switch immediately to run the backup, right? And the backup also has this latch here with the timing bit, but there's one caveat here. The moment the lead becomes available again and we go back to run the pump, we're running the backup pump, let's say, and the lead becomes available again and you go back to run the lead, we don't want the backup to continue to run because of the timing bit, right? Because it could be that the timing bit might be holding it. But we don't want that because we don't want a dual pump running setup. And this could be different too, depending on your application. Your application might allow dual pump running setup, and they might say, no, we want you to actually always respect the timing bit, always respect the minimum runtime. In that case, you will have to modify your code to match those requirements. But let's just kind of run this and see what happens. So we're going to do what's commonly referred to as a unit test. We're going to try to test our code that we wrote here. So we're going to issue that run command, and you see that we have that command, that desired command that is issued, and we had the lead pump that is running, right? Now, let's say we that we fault that pump. Whenever we fault that pump, immediately you see that the backup pump starts running, right? Now, what happened if that lead is actually now back online again? It's back up online. Now we can go back and run that lead. Now, if we turn off the lead command, it's going to continue to run. The lead is going to continue to run until that timing bit expires because we have the minimum runtime. And that's how you actually go about and doing more detailed tests more than this to make sure that everything is running obviously properly. You would test all the edge cases to make sure that nothing breaks on your code. But for the sake of the video and the time that I want to spend here, I'm going to go ahead and um, cut it short at this point. Now, I do want to share that I've wrapped all these three methods into a simple template that you can drop straight into your projects. Variables are already declared and timers are already wired. So if you go into my GitHub page here and you go into this three-way to control a pump, you'll find all that structured text that you just saw. You'll find a little bit of those pictures that I share with you for a reference to a ladder logic if that's what you're comfortable with, right? So you'll find the links in the description to download all these resources, and you're more than welcome to use it as a starting point and adapt it to your standards, or even use it to just study structured text in general. Now, if you want to save time on your future projects, we also have template packs that we offer on our website, and I'll leave the link to those templates also in the description below. Now, if this was helpful, hit like and subscribe before you leave. That really helps us out with the algorithm here in YouTube, and that way we can keep producing this CODESYS or structured text tutorials in the future. And remember, in a real system, you may need more signals like an emergency stop or extra interlocks, more than the very simple examples that we show here today. Now, drop your questions or ideas down in the comments section. Let me know if you want to see more on like pump rotations, alarms, or even reusable function blocks. Thanks for watching, and I'll see you in the next one.